Hello and welcome to the 18th annual exhibit of hydrogen and fuel cell technology. Do have a seat. The drinks are on the house and will be served shortly, so it's time to relax and enjoy some cola or tea or coffee. And join us in a conversation about this very innovative technology, fuel cells and hydrogen. It really is a broad range of technologies. And we're going to be talking to a specialist who's involved in development and implementation and helping us to commercialize all of these products. We'll be talking to Dr. Gunther Kolb, who's head of energy and technology and catalysts at the IMM, which is the Institut für Mikrotechnik in Mainz. Please welcome Dr. Kolb. Hello.
Hello.
Now, whenever I hear institute, I suppose I want to hear, what do you do? So the what is the IMM, the Institut für Mikrotechnik Mainz? What is it?
Yeah, we are a state-owned research institute owned by our federal state of Rhineland-Palatinate. We are located in Mainz, in Germany, close to Frankfurt. And we are an application-oriented research institute. That means we help our industrial customers to bridge the gap between academic research and putting a product onto the marketplace. Basically, we have 5 scientific departments, and besides the energy technology I am heading, we are also working, for example, on microfluidic components for pharmaceutical applications and thin film technology, sensor development, and that kind of stuff. So my department now is focusing on energy technology and catalysis. We also have another department working on fine chemistry for chemical applications. So what we are doing is mostly, and that's the reason why we are here at that booth, mostly fuel processing. That means hydrogen generation for fuel cells. We also work on biodiesel production. We work on heat management systems for aerospace applications, on air conditioning systems and stuff like that. But the main focus is the hydrogen production for fuel cells.
Let's talk about some of the complexities of fuel processing. First of all, fuel processing, obviously you're going from one source of energy to another, and there are various ways of doing it. What are your favorites there? What sort of fuel processing technologies do you use?
So the core of our technology is a plate heat exchanger, which is coated with catalysts. And that plate heat exchanger carries microchannels, very small channels. So now you don't need to be afraid that you have a high pressure drop in such a device. This is not the case. We have laminar flow there, and therefore low pressure drop in the reactor, something in the range of, let's say, 20 millibars, just to give a flavor. And then we coat these plate heat exchangers with catalysts, and this is one of our strengths. We also develop our own catalysts for the fuel processor, different to many other people. And we also have technology to get these plate heat exchangers mass-produced in the future.
Now, whenever I hear, particularly here at the Hanover Fair, when I hear the word catalyst, I also hear the word $ costs. The catalysts are expensive, and if there's any way of reducing the number, the amount of money you have to spend for the catalyst, it's a huge saving. We all know that the fuel cells, the PEM fuel cells, for example, one of the high costs of PEM fuel cells is precisely the materials. There's platinum, for example. So can you offer us any aid in reducing catalysts in this whole process? Is there any money savings involved?
So the core word, let's say, is the utilization of the catalyst. So if you have a commercial industrial scale steam reformer, you usually only utilize about 10% of the catalyst, of the outer surface. So we coat our channels with a thin layer of catalyst, and by these means we can utilize the catalyst fully, which means they have a huge saving of the amount of catalyst you need to introduce into such a device. For example, for fuel processing, people being more familiar with that topic, you know, if you use conventional technology, the biggest reactor will be the water gas shift. So even if you take a monolith, which is already coated with catalyst, the amount of catalyst you need is still double than it is in our reactors, because we can unite the high and the low temperature shift catalyst reactor to a single device. So there are huge potential of savings concerning the amount of catalyst which is in the system.
When we were preparing for the conversation, you used the word screen printing, and it instantly took me to Hollywood and the movies. What exactly is this way of manufacturing the plates you use? Could you describe that?
So for the, let's say, fabrication process of the whole reactor, there are three main steps. The one is how to get the microchannels into the reactor. So we do that either by wet chemical etching or even by embossing, which by this means you then generate corrugated plates. The next step is how to get the catalyst into the microchannels, and that we do with the screen printing. So we have for many years developed a screen printing technology for that, and there is no doubt that that is well suited for a future mass production of the devices. And the last step is then you have to staple the plates and seal them, and that we do by laser welding and not by brazing, how it's usually done for heat exchangers. Why? Because you have catalyst in there, and there are easily a lot of problems created between the brazing filler and the catalyst, and that is avoided by just sealing the device from outside with a very local heat input, which also does not damage the catalyst by temperature excursions.
We in this industry are in the process of finding new markets, niche markets, evolving products that are appropriate for the market, and of course improving what we already do well. And we're always looking for people who help us tailor-make the various products that we could then commercialize. Do you like to deal with these people who come to you and perhaps say, I've got this wonderful idea for a niche market or for a commercial product. We need not only to use your expertise, but we need some help in developing it. So do you jump into the developmental stage as well and help them to move from a good R&D idea or a good market concept to the realization of that concept, even to the point of mass manufacturing?
That's exactly what we are doing. So we start with, let's say, the modeling of the system. We use commercial software, Aspen software, for the system design. We also have modeling capabilities for CFD simulations, so detailed fluid simulations of the fluid flow through the devices. I mentioned already we have catalyst development in-house. We can build the prototypes. We have laser welding in-house. Yeah, we have huge workshops for that. And the next step is then the testing of individual components and of complete systems. So we can also do that. And finally, the mass production techniques we also have available. So we can do screen printing. We have companies, contact the companies who can take over part of these tasks in future for the fabrication of the devices. So you get the full chain from the idea to the product in a single institute.
I should add that Dr. Kolb is willing to take questions from the audience if you have any questions about this approach to developing fuel cells, to his technology in particular. And if there are no questions, I, of course, I'm filled with them. When we were preparing again, we didn't really get into one of the first questions I like to raise is, what sort of applications are you involved in? It is always the applications that get the attention. It's we, the engineers behind the scenes, we're all gray mice, as we say. It's always the applications that get. So what applications have you been involved in developing? Could you give us some examples?
Yeah, for many years we are developing together with the company Truma, which is opposite to our booth, an LPG-based fuel cell system, which is has the application of, first of all, recreational vehicles, but then also other industrial applications. One thing you can see here on the fair is a mobile traffic light system for road construction, for motorways. So there are many applications for that system. It has a power output of 250 watts. We are also working very closely together with PowerCell, which also has a booth here from Sweden, and together with Volvo on an APU system for a truck, which has a higher power output in the range between 3 and 5 kilowatt. And we are working on aerospace applications, different concepts for power supply for airplanes. So also to remove in the far future the gas turbine, which is, some of you might know, which is sitting in the rear part of the plane and generates the power there. And quite a few other applications we are not so much talking about yet.
With all of these applications, there's always the question of how far we've gotten already and how far we have to go. Although I'd like to end on a positive note, before we do that, where exactly are the improvements necessary? When you look at the developmental stages you observe in your interaction with the manufacturers, where are the weak spots that people still have to deal with? What sort of developments are still necessary in order to commercialize on a larger scale hydrogen and fuel cell technologies?
Basically, it takes some time to tackle all the technical problems. But for example, with Truma together, we have done that. And we are very, very close to commercialization there. I would say for many applications, the main issue is still the cost. You might know that creates still a hurdle for the market introduction. This is not the case for the system we have developed together with Truma. So we are very optimistic that this will be on the market extremely soon.
Mm-hmm. And when we look into the large future, of course, there are people, skeptics, who say the viability of this technology is still an open question. There are others who believe that, particularly with what we call in Germany the Energiewende, with the necessity to adjust to a new energy supply. At some point, the fossil fuels are going to run out, and we have to readjust. What's your sense? Do you believe in the long run that there's going to be an increasing demand for fuel cell technology? Do you see a bright future for hydrogen and fuel cell technologies?
Certainly there is, and we have seen that already in the past. So there will be cost developments in the fossil fuel supply sector which make such discussions obsolete. So that happened already. It's going up and down, but at the end it will, I think, decrease dramatically at a certain point. If you are not prepared at that time and have no alternatives on hand, then it's too late.
Yeah, I love this. The debate is over, ladies and gentlemen. Fuel cell technologies are coming. And of course, if they are going to come, there is a question of whether the Germans are going to get enough of the market. If we don't do the development, someone else is going to. Yeah. Here we have a specialist located in Germany. I suppose the last question is, do you believe there is enough German-based research and German-based initiative? Could there be more? Are you comfortable with Germany's position in the international fuel cell community?
So there is a lot of effort made from the German institutes, from the German government. But of course others do more, and we should speed up, not to lose the leading position we have in many fields of that research topic.
Well, that is a wonderful note to wind up this conversation. We should speak up and make sure that we're heard here in Germany, because it is a market that is coming, and it would be great if that market was also generating jobs and revenue here in Germany. And someone who comes from research and from a technology institute and comes along to help us is much appreciated. I'd like to thank you, Dr. Gunther Kolb, who's head of energy technology and catalysis at the IMM, that's Institut für Mikrotechnik Mainz. And it's been a pleasure talking to you and very informative. Thank you very much.
Thank you.
And thank you for the attention. We'll be back in a few minutes. Our next talk is going to be with Anthony Anderson, and he's from Precision Combustion Inc., and they'll be talking about fuel processing and fuel reformers. Stay tuned. We'll be right back. Thank you.